Alright, I thought I'd mention pretty much my view on L naught with respect to limits in general, because I don't think I've mentioned that. So just as a recap, L naught is what you are actually evaluating at L of 0. What you're actually evaluating at when you evaluate a limit as x approaches 0 from the positive side. You're not evaluating at 0, right? You're evaluating as close as possible to 0, right? The next number to the right. 1 over L naught is infinity. 1 over negative L naught is negative infinity. 1 over 0 is undefined. This is why you need to take a limit here. But if you go one step further, so 2 times L naught, that's now finite by definition. Okay, so there's things that occur here with respect to limits in general, right? So when the quote-unquote limit exists, right, regardless of whether the limit exists or not, the limit is always evaluated at L naught away from the target value, because that's the whole point. If you're going to evaluate it at the value, you don't need to take a fucking limit, okay? So this is important. It's subtle, it's tiny, but it's there, right? So when we're taking a limit as x approaches n from the positive side of f of x, we're actually taking f of n plus L naught. That's what we're doing. We're evaluating f of n plus L naught. Okay? This isn't even controversial, I don't think. And if you were doing it from the negative side, then it's f of n minus L naught. Okay. So for a convergent series, this means that a convergent series does not in fact converge to the values they are classically said to converge to, but instead they converge to the value plus or minus L naught, depending on which way they're going. Usually we converge up with a convergent series, so it's going to be your value minus L naught. So like with Newton's series, which grows from 0 towards E, it does not in fact converge towards E, but towards E minus L naught. Right. This is a very subtle, seemingly philosophical point, but it does make limits make way the fuck more sense. So you get people confused about this, and they're like, oh, well, but like 1 on 0 is indeterminate or some bullshit, like, or, yeah, I don't know if that one is, but whatever. Like, you get those kinds of weird claims where, like, we can't, it's undefined, we don't know what it is. Well, there's tons of shit in math that's undefined, but you use it anyway. You just settle on something and that's good enough and it works and it's fine. Why is 0 so magical? Well, it's because you're thinking about it wrong. It's merely the case that L naught is not accessible to arithmetic, and thus it is ignored. Right? It is so fucking tiny that you cannot even approximate it with arithmetical means, right? But it is specifically this inaccessibility which renders infinite series viable in the first place. So it doesn't matter how many terms you have in your infinite series, you're never able to reach the distinction between the value that you think you're going for and the value you think you're going for plus or minus L naught. Right? That distinction between those two values is so fucking tiny, you can't get to it with an infinite series. But that is actually what it's converging towards. Because when you look at how infinite series work, we're talking about limits, and that's what limits are. Ah, what the fuck? So the very reason that an infinite number of terms are required to express the value via conventional arithmetic is that the L naught term is present. That's why an infinite series works. If L naught wasn't there, you could just express it. Alternating series. An alternating series, like this one for the fundamental circle constant, pi on 4, alternates between converging towards L naught over the target and L naught under the target. Okay, so this is the one that I used in that little shitty Python script, which is terrible because I don't like Python. I don't think like a Python programmer, so Python is absolutely horrible for me. Also, Monty Python is fucking trash. It's not funny. If you think it is, you're just stupid. Okay, so this, right? So here, the LNAT term is inconvenient not only because it's not expressible conventionally, but also because it's unclear which flavor of it will actually end up being in the final solution. So again, it's ignored. But again, this is wrong, right? Yeah. Is it over or under? Well, we don't know because it keeps alternating. There isn't a final... It's not going to settle on one of them. But it's also never going to get... It's never going to hit pi on 4. It's actually never even going to hit pi on 4 plus L naught or pi on 4 minus L naught. It's never going to reach either of those. That's what it's converging towards. It's converging towards an oscillation between plus or minus L naught from pi on 4. That's what it's doing. That and the specific nature of that instability is actually, I think, much more interesting than if it was just oscillating around pi on 4. So the L naught term is just as much a valid component of the final solution as the much larger and more obvious value which is classically considered. And understanding that the result of a limit is in fact not identical to the more obvious value is, I feel, a rudimentary requirement to properly handling limits, right? So understanding that you're not evaluating at the point that you're trying to take the limit for, that's why you're taking the limit, because you can't evaluate it. That's the whole fucking point. Jesus Christ. Oy. Anyway, a seeming paradox lies in the fact that despite the value, which infinite series converge to, not being the precise value it's classically claimed to be, it will never be the case that a convergent series will predict terms or digits which are not part of the classical value. That is, a convergent series for E, which has been translated to base 10, will never predict digits which are not part of the decimal expansion of E itself. That is like, once it's gotten far, like, as far as it's actually predicting real digits, because, like, beyond that, it's going to give you trash, right? So, yeah, 1,000 terms of the thing, you should get the first, like, 5 digits, and those aren't going to be wrong, right? Those ones aren't going to be wrong. Those ones that it's giving you reliably, that it's telling you are correct, because, like, you look at the next term and it confirms those digits up to that point. Yeah. Those digits won't ever be wrong, right? But it also can't predict all of them. And this detail is important because the difference from E in the value the series is telling us about occurs in the final digits of the infinite decimal expansion of E. Right? Like, whatever. So say you could get a last digit of E, right? Say you could find that. Okay. That digit of E, the difference between E and E minus L naught cannot be represented in that digit. Right? That's what I'm saying here. Like, that's how small L naught is. It is a quantization of the value space. This is true. Of the vector space. This is true. But it is so inaccessibly tiny that it just doesn't work with arithmetic. Right? So, as far as arithmetic is concerned, no such final digit exists. And thus, every reachable digit will be identical to the corresponding digit of E. Right? So you end up with this sort of weird result that confirms old notions of how things work, but it's sort of annoyingly takes you a little bit further into this, like, what the fuck realm of how can anything be that tiny? There's also the consequence that because 1 on L naught is infinity, and 1 on L naught minus L naught, so just L naught less than that, infinity, is now finite, there is only one infinity. Despite the fact that the 1 on L naught minus L naught is actually inaccessible via arithmetic, so it's still in a sense infinite. Even though it's capped, its scale is capped. So yeah, you end up with these interesting things that fall out of consequences of how limits actually work. Yeah.